In this video, we're going to talk about some special products, some certain patterns that certain products, certain multiplying polynomials can follow. Now, we're only going to be talking about two, but that question that's on your homework, the three special general binomial multiplication patterns that you should be able to recognize, well, this video will talk about two of them. You're going to have to watch the other videos to figure out what the third one is. So go watch the other videos. This one isn't enough. We will talk about two of them, though. The first one I want to talk about is something like this. 2x plus 3 squared. Now, the first thing you need to remember is that this is not 4x squared plus 9. No. Please don't do that. It makes your math teacher very, very unhappy when you make a mistake like this. This is not a coefficient. We can't distribute this. You wouldn't do that to other situations. I mean, you know that 3 squared is the same thing as 3 times 3, and that x squared is the same thing as x times x. So 2x plus 3 squared is 2x plus 3 plus 2x plus 3. And so then we do the double distribution, 2x plus 3, and then plus 3 times 2x plus 3. 2x times 2x, 4x squared, plus 6x, plus another 6x, plus 9. Combining like terms gives me 4x squared plus 12x plus 9. And you notice in this that we end up with some things, some important looking things. We have the first thing squared, the 2x. We have the square of 2x over here. The square of 2x over here on the left. We have the square of the 3 on the other side. And in the middle, we have twice the product of those two things. So it's 2x times 3 plus 2x times 3. That's actually how literally we got that. We had 2x times 3 there, 3 times 2x there, and we ended up with two of those things. So we had 2 times 2x times 3. This pattern, where we have the first part of the binomial squared, the last part of the binomial squared, and then double the product of the two parts of the binomial, this is your pattern. To do this with a general example of a plus b squared, a plus b squared, well, we would do, again, a plus b times a plus b. So that gives me a squared plus ab plus ba plus b squared. But keep in mind that ba is the same thing as ab, so that gives me a squared plus 2ab plus b squared. And it's this pattern, the idea that a plus b squared is equal to a squared plus 2ab plus b squared. This pattern is one of the patterns that you should be able to recognize. The pattern in the binomial, or the polynomial here. If you are looking at a polynomial and you see that it fits this pattern, that means it's a perfect square. It's a square of a binomial, and you could go straight to that binomial multiplication. Now, for what it's worth, the other one, a minus b squared, and you should do this out yourself to verify it, this is equal to a squared minus 2ab plus b squared. So these are two of the three special binomial multiplication patterns that you need to be able to recognize. The point here is that when you're given a polynomial that follows one of those patterns, if you can recognize that pattern, it makes it a lot easier to factor. I'll give you kind of a worst case example. 64x squared plus 176x plus 121. Now, you could do this using splitting the middle, but keep in mind what that would involve you needing to deal with. You would need to find two numbers that add to 176 and multiply to 64 times 121, which is 7,744. You would need to find two numbers that multiply to 7,744 and add to 176. Good luck. If you can recognize this, though, as a perfect square, it makes it a lot easier. We can see that 64x squared, that's the square of 8x. 121, that's the square of 11. Now, it's not enough to just notice that. We got to check the middle thing, too. we have to verify that that's 2 times the product of 8x and 11. Well, 8x times 11 would be 88x, and 2 times 88x is indeed 176x. So this is a perfect square, and it is the square of 8x plus 11. 8x plus 11. The square of the first term, or technically the square root of the first term, and the square root of the last term. Those are the 2 pieces for that perfect square polynomial. And so when you can identify these types of things on site, factoring them becomes a lot easier. We'll do one more example. (9x to the 4 minus 30x squared y squared plus 25y to the 4. 9x to the 4. That's the square of 3x squared. Remember that power inside a power, we just multiply the coefficient, or multiply the exponents. 25y to the 4, that's the square of 5y squared. And negative 30x squared y squared, well, 3x squared times 5y squared, 3x squared times 5y squared gives us 15x squared y squared. And twice that would be 30. So this follows the pattern. In fact, it follows the second pattern. And so that means that this polynomial factors to 3x squared minus 5y squared. Being able to identify these patterns when you see them in the polynomial can make your life much, much easier when you're factoring. If you have a polynomial in your homework, and you will, I'll tell you right now that a couple of these polynomials do work out in this particular manner. If you see one where the splitting the middle method gives you ridiculously big numbers to deal with, maybe try looking to see if one of these 2 patterns will hold for it.